So the next thing is difference between addition and substitution reaction. What are the differences between the two? So let me put substitution reaction here. Substitution reaction here. Let me put addition reaction here. Addition reaction here. Under substitution reaction, 1. A substance replaces another substance in its compound. Why this is a substance is a substance completely combined with another substance, compound or element to form a single product or compound. 2 products are formed. Only one product is formed. Three, it is undergone by saturated hydrocarbons. It is usually undergone by unsaturated hydrocarbons. So 3, we have classification based as per the structure, based on the structure. A, we have aliphatic hydrocarbons. Hydrocarbons arranged in chain form. It could be branch, it could be straight. B, we have cyclic hydrocarbons. Hydrocarbons arranged in ring. They are in ring form. They are called cyclic hydrocarbons. So let's take it one by one. We want to see aliphatic hydrocarbons. Aliphatic hydrocarbons. These are hydrocarbons arranged in chain form. E.g., you have alkanes. And alkynes. They all falls into this category. So aliphatic hydrocarbons. It could be straight chain hydrocarbon, straight chain. It could be branched. Example, if you have something like this, this is a N-butane, normal butane. This is butane arranged in chain form. This is butane. You can have 1, 2, 3. Another one is here. One, two, three, four. 1, 2, hey. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Please take note of that. This is a structure 1. This is another structure. This one is butane. While this one is a propane. You can see the two are arranged in straight form. So you can draw that of a member of alkyne too, so far they are in straight form. So let's consider branched. Branched, meaning aliphatic will be in straight chain or branching. So branched chain. Let me just give you an example like 1, 2, 3, something like this, which we have done. We have done all this. This is 2-methylpropane. This is 2-methylpropane. You can see this is branch 1. So it's either straight chain or branch chain. They fall under hydrocarbons. And the examples, alkanes, alkanes, and cyclic hydrocarbons. 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 Cyclic hydrocarbons. 1. These are hydrocarbons arranged in a ring, what form? Any hydrocarbon arranged in a ring form is called cyclic hydrocarbons. Take note of that. So it divided into 2. Is either we have unsaturated cyclic hydrocarbons, unsaturated cyclic hydrocarbons. E.g., we talk of benzene. Benzene is unsaturated. Benzene. C is H6. C6H, that is benzene. So we have 1, 2, 3, 4. Hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen. That's the structure of benzene, C6H6. This one is known as a unsaturated cyclic hydrocarbon. Please take note of that. And in this regard, it is called aromatic hydrocarbons. Benzene is an aromatic hydrocarbons. We have the condition. This is in A level. They will teach you that when you get to A level. We have the conditions. What are the conditions for a compound, a cyclic compound, to be aromatic? Not all cyclic are aromatic, but all aromatic are cyclic. For something to be aromatic, the conditions are, these are the conditions. 1, it must be cyclic. Cyclic, you consider. It must be conjugated. Finally, it must contain 4n plus 2, I think so, 4n plus 2 pi electrons. 4n plus 2 pi electron. These are the three conditions for a cyclic hydrocarbon to be aromatic. When you see benzene, let's see the number of pi here. 1 pi bond, 1, 2. Anywhere you see double bond is counted as 1, 2, 3, 4, 5, 6. So it has 6 pi electrons. So we are n here. We are n starting from 1, 2, 3, 4, and so on. You can see when you put 1 here, it will be 6. So anything with 6 pi, it belongs to, meaning it is a cycle. But let me put something like 8 pi. Let's see whether you can get 8. When you put 1 here, you get 6. When you put 2 here, it will be 8 plus 2, 10. So 8 can never be amount. So a cyclic hydrocarbons with 8 pi electrons can never be aromatic. Please take note of that, and so on and so forth. These are the conditions. Must be cyclic, conjugated, must contain 4n plus 2 pi electrons. Take note of that. So this one is aromatic. Now let me, before we get to that, what are the sources of benzene? What are the sources of benzene? One of the sources of benzene is polymerization. Polymerization of ethane. Eating of ethane in a red hot tube. Polymerization of ethane is C2A2 is heated, so it will be C6A6 benzene. So the process of obtaining benzene from ethane is known as polymerization. We are coming to that, polymerization. This is one of the sources of. Another sources is we call it destructive from coal. In short, destructive distillation of coal. Under destructive distillation of coal, we noted that benzene is a cyclic unsaturated cyclic hydrocarbon, and it is aromatic. That benzene is highly unsaturated hydrocarbon. Is highly unsaturated hydrocarbon. Take note of it. But it undergoes substitution. It undergoes substitution reaction. We said substitution reaction is undergone by saturated hydrocarbon, but this one is unsaturated, but it can undergo substitution reaction. So please take note of that. It can undergo. Reason. Let's see the reason for this. This is because the double bonds, that is electrons, double bonds or electrons in benzene are enclosed within the structure, or within the structure. The double bonds in benzene are included in the structure and cannot be released for reaction. The double bonds are enclosed within the structure and cannot be released for reaction. That's why it will undergo. And the substitution reaction in benzene is called, the substitution is called halogenation. Take note of that. It's halogenation. What makes benzene to undergo substitution? Because the bonds are enclosed and they cannot be released. They cannot take part in the reaction. They cannot be released. So this is because the double bonds in benzene are enclosed within the structure and cannot be released for reaction. So the substitution reaction in benzene is called halogenation. Let's see the meaning. C6H6 plus, let's say, bromine, for example. This is known as a halogenation. The process is halogenation. So it will undergo C6H5Br plus HBr. You can see this substitution reaction can only occur during halogenation. Please take note of that. That is it. Number one, you need to know about benzene here. Then unsaturated cyclic hydrocarbons or aromatic. Another thing you need to know here, the double bonds, many electrons revolve within the structure. The double bonds revolve within the structure. Please take note of that. Or compound. I'm still talking of benzene. The double bonds revolve within the structure or compound, and observing resonance. The double bonds or electron revolve within the structure or compound and observing resonance. We call it a vibration. So name some compound that can undergo resonance, or this resonance, another we call it a mesomerism. So for that reason, you will see different structures of benzene. We have the calculate structure of benzene. You have different structure. You will see it when we get to benzene as a topic. So the following, it means benzene, NO2, SO3, NO3 minus, do undergo, and etc. do undergo resonance. They undergo resonance, mesomerism. Please take note of that. It's very, very important. So if you are asked why benzene, because of its high unsaturation, it's not expected to undergo substitution, but yet it undergo substitution reaction is a result of the double bonds in benzene are enclosed within the structure or within the ring or structure, and they are not allowed or they are not exposed to react. So the substitution reaction in benzene is called halogenation. That's another thing you need to know with benzene. Also, benzene equally undergoes addition reaction called hydrogenation in the presence of nickel or platinum in the presence of catalyst. We call it catalytic hydrogenation of a benzene. It will form C6H6 plus hydrogen. I put 3 here, so it will be C6 then H12. This is known as a cyclohexane. Call it cyclohexane. This is what it will form, cyclohexane. So the conversion of benzene to cyclohexane, we call it a hydrogenation. So what is the product of catalytic hydrogenation of benzene? We call cyclohexane. We talk of saturated cyclic hydrocarbons. Hydrocarbons. E.g., we talk of cyclohexane. Take note of that. C6H12. Cyclohexane is formed from benzene by catalytic hydrogenation. Catalyst, nickel or platinum catalyst, to form C6H12. Take note of that. This is benzene. We call it catalytic hydrogenation of benzene yields cyclohexane, and the structure is like this: 1, 2, 3, 4, 5, 6. So we have 2 hydrogen each. We have hydrogen. We have hydrogen. We have hydrogen. We have another hydrogen here. We have hydrogen. We have hydrogen. We have hydrogen. We have hydrogen. This is C6H12. C6H12. You know, it is now saturated. Take note of that. It's an example of saturated cyclic hydrocarbon, but it is not aromatic. Now, if C6H12 is now converted to benzene, meaning from non-aromatic to aromatic, using catalyst. The conversion of a non-aromatic, e.g., cyclohexane to benzene. You are converting it back. This process is known as aromatization. We call it aromatization. It's the conversion of non-aromatic hydrocarbon to aromatic hydrocarbon, that e.g. cyclohexane to benzene.